Learn about noise sources in audio amplifiers and how to eliminate them using proper component selection. Audio amplifiers can produce unwanted buzzing, popping, and noise that degrades sound quality. Understanding the sources and solutions is essential for clean audio. Let's identify the main sources of noise in audio amplifier circuits. Power supply ripple from inadequate filtering causes 50 or 60 Hz hum in the audio signal. This waveform shows AC ripple voltage that appears on the power supply rail when filtering is insufficient. Electromagnetic interference from transformers, motors, and digital circuits couples into sensitive amplifier stages. Ground loops occur when multiple ground connections create current loops that pick up noise and inject it into the signal path. All resistors and active devices generate thermal noise proportional to temperature and bandwidth. Popcorn noise comes from contaminated semiconductor junctions producing random voltage spikes. Proper power supply decoupling is the first line of defense against noise. A decoupling capacitor placed close to the power pin shunts high-frequency noise to ground, preventing it from entering the circuit. Capacitor impedance decreases with frequency, making it effective at shorting high-frequency noise to ground. Place 100 nanofarad ceramic capacitors as close as possible to each integrated circuit power pin for high-frequency decoupling. Larger electrolytic capacitors from 10 to 100 microfarads handle low-frequency ripple and bulk energy storage. This parallel combination of ceramic and electrolytic capacitors provides broadband filtering across the entire frequency spectrum. The input stage is most sensitive to noise and requires careful filtering design. An RC low-pass filter at the input removes high-frequency noise and radio frequency interference before amplification. The cutoff frequency is determined by the product of resistance and capacitance values. Set the cutoff frequency above the audio band, typically between 30 and 50 kHz, to filter RF without affecting audio. A typical input filter uses a 1 kΩ resistor with a 4.7 nanofarad capacitor for approximately 34 kHz cutoff. Proper grounding techniques are critical for eliminating ground loop noise. Star grounding connects all ground returns to a single central point, preventing ground loops and ensuring all circuits reference the same ground potential. A continuous ground plane on the printed circuit board provides low impedance return paths for all signals. Keep analog and digital ground separated and connect them at a single point to prevent digital noise from contaminating analog circuits. Route high current paths like speaker outputs away from sensitive low-level input circuitry to avoid magnetic coupling. Physical shielding and wire routing techniques reduce electromagnetic interference pickup. Shielded cables with grounded metal braiding block external electromagnetic fields from inducing noise on signal conductors. Always use shielded cables for input connections and ground the shield at one end only to avoid ground loops. Twisted pair wiring causes magnetic fields to cancel because both wires experience equal but opposite induced currents. Minimize cable length and maintain separation from power wiring to reduce capacitive and inductive coupling of noise. Choosing the right components significantly impacts overall circuit noise performance. Metal film resistors generate less thermal noise than carbon composition types and have better temperature stability. Thermal noise voltage equals the square root of 4 times Boltzmann, constant times temperature times resistance times bandwidth. Since noise is proportional to square root of resistance, using lower resistance values where possible reduces thermal noise. Choose operational amplifiers with low input voltage noise and current noise specifications for critical input amplification stages. Electrolytic capacitors can add distortion and noise, so use film capacitors in the direct signal path for best performance. Inductors and ferrite beads provide complementary filtering for specific noise scenarios. A ferrite bead acts as a frequency-dependent resistor, providing high impedance to high-frequency noise while passing DC and audio frequencies. Install ferrite beads on power supply lines to block high-frequency noise from digital circuits or switching regulators. Inductive impedance increases linearly with frequency, making inductors effective high-frequency filters. Unlike resistors, inductors filter AC noise without dropping DC voltage, making them ideal for power supply filtering. An LC filter combining an inductor and capacitor creates a highly effective power supply filter with sharp cutoff characteristics. Here is a systematic approach to eliminating noise from audio amplifier circuits. Begin by ensuring the power supply has adequate filtering with both bulk and ceramic capacitors, plus voltage regulation. Establish proper grounding with star topology and continuous ground plane to eliminate ground loops. Install RC low-pass filters at all inputs to reject radio frequency interference before amplification. Place decoupling capacitors within 5 mm of every integrated circuit power pin for effective high-frequency filtering. Route all signal cables away from power lines, use shielding where necessary, and keep cables as short as possible. Choose metal film resistors, low-noise op-amps, and quality film capacitors for input and feedback networks. Let's review the key points for achieving clean, noise-free audio amplification. These 4 pillars form the foundation of low-noise amplifier design: filtering, grounding, shielding, and component quality. Capacitors are essential for filtering high-frequency noise and providing local energy storage for stable operation. Resistors work with capacitors to create filters and limit circuit bandwidth, reducing noise while preserving audio. Inductors provide frequency-selective filtering on power lines without the voltage drop associated with resistors. Following a systematic methodology, starting with power supply and grounding, leads to successful noise elimination in audio amplifiers.